Hello everybody, we're going to do Algebra 1, 2.1.3. And similar to how we did the last video, as I'm going to work directly off of the checkup problems for this section. So I'm taking these example problems from 2.1.2 checkup. That's in your Apex. Alright, so that's where I'm getting these example from. So let's just jump right on into it. So, the first question, the last thing we did was we did one step solving for a variable, basically. Here we're going to do, these are going to now be multiple steps. So instead of just doing one and being done, now we're going to do a couple, maybe even more. So the first example is going to be negative 2x plus 18 equals 24. All right, first step's still the same. I'm going to draw my river. And now I'm going to ask myself, what am I solving for? Well, I'm solving for the x. What's on the same side as the x? Well, now what's on the same side of the x is a negative 2 and an 18. So we actually have a couple things on the same side as the x. All right, so I'm going to add an additional question into this. What's the furthest away from the x? All right, which piece of this equation, the negative 2 or the 18, is the furthest away? Well, the negative 2 is multiplying that x right next to it, and then the 18 is adding it. All right, so what I'm going to say is since the 18 is like off to the side and adding, I'm going to say the 18 is the furthest away from x. So how do you get rid of addition? You subtract. So on my first step here is I'm going to subtract 18 from both sides. That cancels there. I bring the entirety of the negative 2x down. And now 24 minus 18 is going to give us 6. All right, what am I solving for? X still. What's on the same side as x? Well, now only the negative 2 is on the same side as the x. And what is that negative 2 doing? Well, we already kind of said it. It was multiplying. How do you get rid of multiplication? Well, you divide. So I'm going to divide both sides by the negative 2. Right? Bring the negative with it. That cancels. I'm left with just x. And then 6 divided by negative 2 is negative 3. And boom, I'm done. So before, we were only doing one of these twos. We would either subtract the 18 and then we would just have x by itself, or we would divide by the negative 2, we'd have the x by itself. For this section, we're going to be doing multiple steps. All right, and that's okay. We can do that. I believe in y'all. All right, so question 2 from the checkup problems 2, 1, 2. We have 3x plus 2x plus 9 equals 10 minus 14. So I'm going to go ahead and draw my river. Now this one has an additional step here, right? So now what I'm going to do is I'm going to look at the left side of the equation. I have a 3x plus 2x plus 9, and I'm going to ask myself, are any of these like terms? Now, what is a like term? A like term is determined by the variable and the exponent. So, for example, if down here I have x squared, say I had x squared plus 3x squared, because they both had x squares, they had the same variable and the same exponent, I can add those together. So I have x squared plus 3x squared, that's going to be a 4x squared. All right, so if I have an x term with no variable, or I guess if I have this scenario, this is technically a variable of 1, an exponent of 1, I mean, be 3x plus 2x is going to be 5x. I add the coefficients and I bring that term down. If I have this scenario, 3x plus 2x squared, so we have one x term with no exponent, even though we know it's a 1, we just don't write it. And then we have a 2x squared. These are not like terms, so we can't combine them. So we will just leave them as 3x and 2x squared. All right, so over here, we have 3x and 2x. They are like terms. They both have the same variable and the same exponent. So that tells me I can now add these together. 3x and 2x is 5x. This 9 does not have an x, so it is not a like term, so I'm going to leave it alone. Now on the right side, I have a 10 minus 14. Now they both don't have a variable, which means that they are like terms. All right, so they share the same variable, which isn't 1. So they are still considered like terms. 10 minus 14 is going to be a negative 4. So there may be some problems that we need to do a few steps on the sides individually first before we get into our solving. Now, my question I'm going to ask is, what are we solving for? We're solving for x. What is on the same side as the x? Well, we have that 5 and that 9. And that question I added this quiz is, what is the furthest away from the x? Well, the 5's multiplying and the 9 is just being added. The 9 is the furthest away. So how do I get rid of that 9? Well, I subtract it. It's adding, so I'm going to go ahead and I'm going to subtract. So I subtract 9 from both sides. That cancels on this side. I'm left with just 5x. Then over here, I have negative 4 minus 9. That's going to be a negative 13. And then, what am I solving for? I'm solving for x. What's on the same side as x? The 5. How do you get rid of the 5? Well, it's multiplying, so I'm going to divide. I divide both sides by 5. And my answer is x equals negative 13 divided by 5. If you plug the negative 13 divided by 5 in a calculator, you're going to get some decimal, 2 point something. Will be a negative 2 point something. We don't need that decimal. It's fine. We can leave it as negative 13 over 5. It's not a pretty answer, but we will learn to accept the fact that many of our answers will not be pretty. All right. So x equals negative 13 over 5 is an acceptable answer. All right. I'm now going to go to question 3. We have 6x plus 2 equals 42. I'm going to start everything the exact same way by drawing my river. Now I'm going to look at the left side and ask myself, can I simplify this in any way? And I can. How do I simplify this? Well, what we have is we have a parentheses that has an x plus 2. Then we have a 6 outside of it. There's no plus sign, there's no minus sign, there's no division sign, there's nothing. It's just right next to the parentheses. Well, we're going to call that multiplication. Just like this 5x, this was a 5 times x. All right, so when there's no sign between them, we're going to consider it multiplication. So now I have this 6 that's multiplying a parentheses. Now, what we're going to be looking for is the opportunity or the ability to distribute this. So we're going to use the distributive property here. All right, so because we have this 6 outside the parentheses with nothing in between it, so there's no plus sign, no minus sign, no division sign or anything. It's just right next to parentheses. It's multiplication, so I'm going to distribute. So this is going to be a 6 times x and then a 6 times 2. And if there was more in this parentheses, I would multiply that 6 by everything. I'm distributing it to everything. So 6 times x is 6x. 6 times 2 is 12. And then my right side, there's nothing for me to do, so I'm just going to leave it as 42. All right, so we have 6x plus 12 equals 42. Now I'm going to do the same steps I was doing before. What am I solving for? I'm solving for x. What's on the same side as x? Well, the 6 and the 12. What's the furthest away? That 12 is the furthest away. What's it doing? It's adding. How do you get rid of addition? Subtraction. So we have a plus 12, so I'm going to subtract 12 from both sides. That cancels there. Now I have a 6x equals 30. Now, what am I solving for? I'm solving for x. What's on the same side as x? Well, the 6. What is the 6 doing to the x? Well, it's multiplying. How do you get rid of multiplication? You divide. So you're going to have x equals, well, 30 divided by 6 is 5. And there's my final answer. Now let's find me another example. Oh, yes, we're going to do number 5. So do number 5 here. So we have 7, 14 minus x equals 3x plus 18. All right, this one's going to be even more complicated, but it's okay. We know our sets. We can get this done. I'm going to look at the left side by itself. Is there any way I can simplify this? Well, I have a 7 outside of a parentheses with no other sign, so it's just right next to the parentheses. I know that's multiplication, which means I can distribute this 7. Well, 7 times 14 is 98, and then we're going to have a 7x. Now, on the right side, I have a 3x and an 18, so one term has an x, and the other one does not have an x, so they're not like terms, so I cannot combine them, so I just got to kind of leave them. All right, so we have a 3x plus 18 on the right side. All right, now, so what am I solving for? I'm solving for x. But right now, I have x terms on both sides of this equation. All right, I have x terms on both sides of this equation. So I have negative 7x on the left, and I have positive 3x on the right. So what I'm going to look for is I'm going to look for the biggest number. All right, so we have a 7 and a 3. Well, 7's the bigger number. All right. Now, the 7 is negative. So because it's negative, I'm going to go ahead and add it over. All right, I'll do an example the other way here in a second. So because this 7 is the biggest number and it's negative, my first step is going to be adding 7x to both sides. So it'll be 10x plus 18. So now I have one variable, the x. That's what I'm solving for. What's on the same side as that x? Well, the 10 and the 18. What's the furthest away? That 18. And what's the 18 doing? Well, it's adding. How do you get rid of addition? Well, I'm going to subtract. So I subtract 18 from both sides. Well, 98 minus 18 is going to be 80. And that's going to be equal to 10x. All right, now what's happening to the x? Well, it is being multiplied by 10. So now I'm going to divide by 10, and I have 8 equals x. Now, I'm going to redo this problem, and I'm going to write it a little bit different. So say this was a 98 plus 7x equals 3x plus 18. So now, what's the biggest number between my two x terms? Well, it's that 7, right? And it's positive. So the biggest number is positive. So I'm going to now, instead of bringing the 7 over to the right, like I did before, I'm going to subtract the 3 now. And obviously our answer is going to be all different because this is an entirely different problem. It'll be equal to this. So for clarity, if I'm looking for the biggest number for my x, all right, and if it's negative, I'm going to go ahead and add that biggest number to both sides. In this case, if the biggest number is positive, I'm going to go ahead and add or subtract the other variable on the other side and bring it over. All right, so the only time I would be moving the biggest the biggest term, the biggest variable term would be if it's negative. So the negative 7x, because it's the biggest number, I'm adding it to the other side. And the reason being is if I did this problem again, like I'll go ahead and do it again with the actual problem. So we had 98 minus 7x equals 3x plus 18. Like I could have subtracted this negative 3x from both sides. That would give me a 98 minus 10x. And that's equal to 18. And then I'll need to subtract the 98. That would be a negative 10x equals, what's that going to be, a negative 80? And then I'll need to divide by a negative 10. So the reason why I'm encouraging you, because I get the same answer, right? I got the same answer either way. So not like I get different answers by doing it a different way. It's just that I eliminated the need for a negative. And we want to look for the opportunities to not have a negative because we can drop a negative sign, forget about it, and we just get the wrong answer even though we understand it. So we always want to look for the opportunities to keep our x term specifically positive. So this was a negative 7x. That's why I chose to add it first. All right, see if I can find... Okay, so they will also ask you if there is, how many solutions to a problem. So question 8 is identify the number of solutions to 2x plus 5 equals 2x plus 3. All right, so that's the problem, and it's just asking me that. It doesn't want to know what the solution is, just wants to know how many solutions there are. All right, and what we look for, there's 3 options when they're asking this question. Is we could have one solution, in which case you would get x equals some number. That'd be one solution. So almost every problem that we've done thus far, we've got x equals a single number. That is one solution. We could get something that's infinite solutions, or infinitely many maybe. And that's when you get like your final answer is an x equals an x, or an 8 equals an 8. It's where the left side equals exactly the right side. So it could be a 3x plus 2 equals a 3x plus 2. As long as the left side is equal to the right side, meaning they're exactly the same, that's the infinite number of solutions. And then no solution is when you get something that's not true. 8 doesn't equal 4, 7 does not equal -3, etc. So no solution is when you get something that's not true. So if I go to this example, well, I have an opportunity to distribute again. I have a 2 outside of parentheses with nothing in between it. So I'm going to go ahead and multiply that. Goodness. So we have 2 times x is 2x. 2 times 3 is 6. All right, so I have x's on both sides. I want to combine them first. They are both the same size, and they're both positive, so I don't have any particular detail what I want to do. So I'm just going to go ahead and subtract 2x from both sides. Well, when I subtract 2x from both sides, the x term actually cancels out entirely, and I'm left with 5 equals 6. And does 5 equal 6? Absolutely not. That's not true. So we got something that's not true. Well, that tells me that this problem has no solutions. All right, and that's what we're looking for. So every other example we've had were examples of one solution. And then we just did an example of no solution, then I'll do an example for infinite solutions. This is a question 9 on the checkup. All right, so I have an opportunity to distribute again. So I have 3x plus 21. So now I'm going to go ahead and stop right now. Now we could continue and just keep doing it. But on the left side, I have a 3x plus 21. On the right side, I have a 3x plus 21. They're the exact same on both sides, the exact same. That tells me there are infinite number of solutions. So we've now done examples where we got one solution, x equals a single number. We did an example where we got no solutions because we got 5 equals 6, which isn't true. And then we have an example where we had infinite number of solutions. And that is when the left side is equal to the right side exactly. They're the exact same thing. Now, I think that's all for today.